In this session, we'll get started with the SQL SELECT statement. You'll do most of your work in SQL using variations of the SELECT statement. This is such a big topic that we'll have several sessions in this course for this statement. One of the simplest types of SELECT statements is shown here. On this slide, near the top of the tab, you see the SELECT statement. It uses color coding for the SQL SELECT and FROM keywords. On this SELECT statement, the FROM keyword is used to specify the table name that the data is to be retrieved from. If you haven't worked with SQL before, the most curious part of this statement is probably the asterisk character, sometimes called star. When used in a SELECT statement, the asterisk has a special meaning. It means that all of the columns that are defined in the table are to be retrieved. When the asterisk is used, it is usually referred to as a select all statement. When this select statement is run, it retrieves data from the city table. The data is displayed in the result grid. Of data that is retrieved from a select statement is sometimes referred to as a result set. If you write a program that runs select statements, you'll use features of your programming language to work with the result set. What happens if you run a select statement and there is no data in the table? In that case, you have an empty result set. The statement is valid and it will run without error. There just won't be any results. What happens if you run a select statement like that shown here and there are millions of rows in the table? Using a statement like this, all of the rows in the table will be retrieved. You'll learn how to limit the data that is retrieved in a select. Here you see a variation of the select statement. The variation here is that 3 column names are specified rather than using select all. When you specify column names, data is retrieved only from those columns. You might wonder why you would want to use this variation. After all, it would be a lot faster to just type a single asterisk character instead of the list of column names. In fact, for most applications, it is always best to specify just the column names that you need. Some tables might include dozens or even hundreds of columns. It is unlikely that you need to work with all of the data in all of the columns. It is considered to be a best practice to specify column names rather than use the select all. The reason why is because when you limit your column selections to just the data that you actually need, the database management system doesn't have to move as much data to get the results set ready. As with most performance issues, if you just try running a select all statement on your PC or Mac, you will not see any difference. It will be just as fast as if you had specified a column list. But if you run a database like MySQL in a server environment, for example, as the backend database for a web application, the cumulative effect of many select statements will be a factor. If a database-driven website is running too slow, one of the things to look into is if the select statements are select all instead of limiting the columns to just those that are needed. This slide shows the 2 select statements that were used on the previous slides. You can see the complete statements here. The table lists the words or symbols that are used along with a brief description of the usage. SQL keywords can be typed as all uppercase, as select and from are here, as all lowercase, or as mixed case. Column, schema, and table names can usually be typed however you want, but there are some exceptions with names, and different database management systems might have different rules. This slide shows the order of columns when a select all is used. On the left, you see the columns for the city table as shown in the navigator part of phpMyAdmin. The columns are listed in alphabetical order. When you run the select all, the columns are returned to the result set in the same order in which they were defined. In some cases, the order does not matter. For example, if you code a select statement to use in a web application where you are writing a program to display the results, you can usually control the order in which the columns are displayed in your programming language. Sometimes you will want the columns in a result set to be in a particular order. For example, if you are running a select statement that will be used to bring data into an Excel worksheet, you might want the data to be in a certain order. You can specify the column order that you want when you use a select with a column list. On this slide, you see that the select lists 3 columns: name, country code, population, in that order. Here is a variation of the select statement. This select does not have a from clause, so it is not selecting data from a table. Strangely enough, it does produce a result set. The strange part is, because there is no from clause, there is no table, and therefore no column names to put into the select list. In this example, the 2 columns are named 1 and A. You can see in the result grid that there is a row in the result set, and that it indeed has 2 columns named 1 and A. You can also see that the data values for those columns are set to 1 and A. Here's another example of a select statement that does not have a from clause. So once again, there is no table and no columns to select from. This time, though, you'll see that the data that is displayed is more useful. In this case, the columns that are specified on the select list are 2 MySQL functions: current date and current time. You can tell that these are function names and not column names, since the columns both end with opening and closing parentheses. When you run this select, the current date and time are retrieved. The date and time are based on the system date and time, so if you run this on your machine, you'll see the current values on your machine. You'll find that being able to run a select with no from clause is useful for running quick tests of functions. Rather than have to work with actual data, you can simply enter the statement to test a function. Once you've seen how the function works, you can then use it in a statement that works with data.